one more chapter of your syllabus which has been chosen from part 1 textbook. It is the 8th chapter, that is Gravitation. Here in this chapter we are going to study about the earth, its motion, certain laws which are there being used to study motion of the earth as well as motion of other planets around. So we are familiar with Newton's observation of falling of an apple on its head when he was sitting below the apple tree. So by observing the motion of that apple towards the earth, he analyzed the motion, then he gave one important law that is known as Newton's law of gravitation, wherein he had given the data related with what? How an object is forced to move towards the earth, and thus gave us an idea related with that. Yes, earth is an object which will attract other objects towards it, and with the help of that we have analyzed various contents related to what? Earth. We have studied about the force, whether it has been exerted only by the earth or by other planets. We have seen that our earth is lying, or we know that our earth is a part of sun, and that sun is again a part of a galaxy. Ours is a Milky Way galaxy. Then that Milky Way galaxy is again a very small part of the whole universe, and we are still unknown of many other things, that there may be some number of galaxies around us, there may be n number of earth like planets around us. So this concept, that is a study of astrology, astronomy, is included in the concept of astrophysics, and to understand it we need to study certain important laws. So apart from the Newton, various other scientists also gave various important contribution to this content, whatever we are now knowing, means till now whatever we know. Further, first person who contributed most is Ptolemy. Ptolemy, that is a person who before 2000 years back he gave one important law or model related with motion of the earth. That is, he said that our system is now under geocentric model. The term geo is indicating the earth. So it indicates that the earth is lying at the center and the other planets, the sun, the satellites, they are moving around the earth. So this was the first consideration made by whom? Ptolemy. That was again 2000 years before back. So the model is called as geocentric model. That is, earth is lying at the center of that whole system. Then Aryabhata in the 5th century, he just changed that thing. By observing whatever things are now around him, he gave one more model called as heliocentric model. Helio, it indicates the sun, means sun is lying somewhere at the center and the remaining planets, they are revolving around that sun. Your earth, the Venus, the Mercury, the Jupiter, any planet if you take, that planets are moving around the earth. So, sun. So this thing, that is, sun was considered to be lying at the center, was given by whom? Aryabhata. And till now this model is being used, or it is the actuality, but in that certain modifications were made further. So a person known as Nicholas Copernicus, he said that yes, the other planets, they are moving around the sun, wherein sun is lying at some point, and he gave the orbital motions, means the planets which are there, they are revolving around the sun in a particular orbit, whether as a rectangle, whether that orbit is a square, or some other. So he said that the orbit being followed by the planets, it is circular in nature, wherein the sun is exactly lying at the center. Means if this is the orbit, this is the position of the sun, okay, other planets will be revolving like this around the sun. So this was the model being given by whom? Copernicus. So he gave the idea of orbit of motion. Means along what path the planets they are moving around the sun was given by whom? Copernicus. Later on, a person Galileo, he also followed the same thing being given by Nicholas. Okay, that is the sun is lying at the center of that circular orbit, and along those orbits the planets they are moving. And apart from it, he added one point, that is other objects which are there around the sun, okay, or which are there around the earth, they are being attracted towards the earth. They are being what? Attracted towards the earth, and they move with some constant acceleration towards the earth. Means when an object is coming towards the earth, it will have some constant acceleration. And later on, the value for acceleration basically for the earth, it is found to be equivalent to how much? In the last chapter we have studied this 9.8 meter per second square. Means with this acceleration, the objects which are lying on the surface of the earth, they will move. This is the constant value for acceleration, and it is called as what? Acceleration due to gravity. So the Galileo gave that idea that it is moving with certain constant acceleration. Then a person known as Tycho Brahe, one of the important person in the history, he spent his whole life in observing the sky, okay, without any instrument, just with the naked eyes. He observed the planets, he observed the motion of the stars, and he gave some written data related with what? This is the motion, this is the time period it is taking for a particular planet to again reappear. In this path they are moving towards the east, towards the west, and they reappear after certain time. These planets, one planet, Mercury and the Earth, they will be closer at this duration of the year, they will be farther at this duration of the year. So this observation was made by what? Tycho Brahe, and he gave some data related to the motion. And the other person, that is Kepler, he studied this data being written by whom? Brahe. He analyzed everything, whatever data has been written by him, and then he gave 3 important laws related to the motion, and that laws are called as what? Kepler's laws of motion. And apart from it, he just changed the idea that the planets, they are revolving around the sun, not in a circular orbit, but the orbit is elliptical in nature. We will see what is this elliptical means. So instead of motion along the circular path, the planets are supposed to be moving along the elliptical path around the sun. This was the idea being given by him. So we will study the important laws being given by him, that is Kepler. First law is known as Kepler's law of orbit. Means here we are getting an idea related with what? Orbit of motion, that is the path being travelled by the planets. So he says that all the planets which are there in our solar system, they move in an elliptical orbit. They are moving in an elliptical orbit. So this is the nature of an elliptical orbit. Okay. This is the circular, but this is what? Elliptical nature. So all the planets which are there, they are moving. If you take one planet P here, it is moving in along an elliptical orbit around the sun, And one more condition he gave, that instead of lying at the center of that orbit, the sun, it lies at one of the foci. So if I go with this structure, which is an ellipse, it has two axes. One, the shortest one, it is known as minor axis. Okay, and this longest one, it is called as major axis. It is called as major axis. So there are 2 points which are there on the major axis, and these points are known as focuses. What it is called as focus, individual points. Together they are pronounced as foci, F-O-C-I. Together foci. So your planet is revolving around the sun in elliptical orbit, and the sun is lying at one of the focal point. Either you can consider here the position, or you can consider the position of the sun along this focus. Okay, so let us take, this is the position of the sun and this is the motion of the planet around it. So he gave the idea related to what? Orbit of motion, and what is the position of the sun. It may lie here, not at the center, no, not here. And one more thing he gave, that we have 2 points in the orbit. That is, if your sun lies here, the planet revolves around it, and the point where it reaches the minimum distance from the sun, that point it is called as perihelion. The point of the smallest distance. It is the point of what? Smallest distance of the planet from the sun is called as what? Perihelion. Then we have another point which is the farthest. Means if your planet revolves further, it reaches this point, and this is the position of the sun. So this distance is the largest distance, and that point where it reaches the farthest distance is called as what? Ephelion. It is called as ephelion. So the statement of your Kepler's orbit law, we will see. All planets, they move in elliptical orbit. The orbit is what? Elliptical in nature, wherein the position of the sun they have given. The position of sun is lying at the foci of that particular ellipse. So you can choose any, maybe the focal point for position of the sun. Then we will go with the second law. The second law is called as the law of areas. It is related with area being covered by the planet. So when the planet is revolving around the sun in an elliptical orbit, its velocity is found to be differing. So you might have observed that some days are shorter, some days will be longer. The duration of day will be longer, and some days the sun may go down within very short, within 6 o'clock it will, and some days 7, 7:30, 7:15, so on. So during that the days will be longer, and here it is basically related with what? Motion of the earth. If your earth revolves with higher velocity, moves faster, then the day will be shorter. If it moves slowly, then the time taken will be larger. So it again depends upon the position of the earth, whether it is lying towards the sun or away from the sun. In generally, if you take a planet, it is related with area being covered by the planet. So if this is the motion of a planet, this is the minor axis, this is the major axis. This is the position of the sun, this is the planet being revolving. When it revolves, it is said that the line joining the sun and the planet. So if I take the sun and the planet, I will join them by using the line. This line will sweep out, it will move out certain area, and that area will be equal to, so this is the distance. Let us take that the planet is lying here, it shifts to this position around that elliptical orbit. So during that motion, what is the area being covered by it? It is equal to, in the same time interval, if this is equal to t, then in that same time period, it should cover the same distance or area in some other place. Means if it lies here, then within that time t, it should cover same area as this. If this is the area, same area it should cover. So this will be the area. So it will be the new position of the planet. Similarly here, you can take, this is the initial position, this may be the final. So this area, all these areas A1, A2, A3 should be same for some constant time interval. Means for 1 month, if you take, it should cover the same area. Okay. Then it is said that the aerial velocity of the planet should remain constant. It should remain constant. So it is denoted by dA upon dt, which is equal to a constant. So just now I have said about longer days, shorter days. So it is basically depending upon this. If your planet is here, it needs to cover very short distance. So therefore it will move slowly. Within 1 month it will move here. When it reaches here, it has to cover same area. Therefore it will need to move at this point. So how it will do? It has to cover this much of path. So how it is done? It needs to faster the rate of motion. So it will move faster to cover up this much of distance. Is the point clear? So in this case, the days will be shorter. In this case, the days will be longer. So it is depending upon, that is, it tries to keep the aerial velocity constant. So the statement is like this: the line joining the sun and the planet will sweep equal area in equal interval of what? Time. Or generally you can say that the aerial velocity is remaining constant for that planet. Is the point clear? Then we will go with the third law, that is known as law of periods. Periods is nothing but time period. So what is time period? It is the time taken to complete one oscillation on one revolution. This object is here, it will move like this, it will come back to the same initial position. So what is the time it takes to complete one rotation, one motion, complete motion? That time is called as what? Time period. It is called as time period. So if you go or consider any planet, it will have its own time period. So our Earth will take how many days? 365 days to complete one rotation around the planet, isn't it? So around the sun. Other planets may take different time intervals to complete its motion. So it is found that the time period is related with what? Its position around the Earth. Its position around the Earth. And it says that the square of the time period for any planet, if you take, square of its time period is proportional to, it is proportional to what? The factor cube of semi-major axis. What does the term indicate? Semi-major. This is a major, this axis, semi, half of it. So if I take this as the distance, semi-major distance r, or I will show it here. This distance is your semi-major distance r. So it is found that the t square is directly proportional to r cube. This is called as proportionality constant. Means this factor is directly proportional to this. If this is increasing, this also increases by the factor. If it is increasing by t square, it will increase by cube. Is the point clear? So it says that for every planet, the time period of revolution, its square is found to be proportional to cube of the semi-major axis. Cube of the semi-major axis. Just take example of planet which is very nearer to the sun. If you take Mercury, lying near the sun. So for its orbit be very shorter. So this is the sun. This orbit will be the Mercury's orbit. So for it, this distance is short, isn't it? So therefore, time period will be small for it. Time period of revolution will be smaller. If you go with the Jupiter, it is lying farther away from the sun. So this will be its time, okay, orbit. So for it, the R value will be larger, isn't it? The value for R will be larger. So thus, your time period or time taken by the planet to revolve around the sun will also be. So it basically depends upon R value, how your T is changing. So it is said that the T square is directly proportional to R cube. It is directly proportional to what? R cube. So these are three important laws which will give us an idea that how the objects or the planets, they are revolving around the sun. So first is the law of orbit, gives an idea related with the path of motion. Then is the areal law, wherein it will give us that whether it is covering same area, what is the nature of motion, it will move faster or slower, that idea will be given here. Then the next is the orbital, the law of periods, wherein it will give you the idea related with what? The time period of motion, means how much time it will take to complete one revolution around the sun. And it is again related with the orbit of motion by the factor what? Semi-major axis value R. Okay. Then we will go with one more important law, that is known as universal law of gravitation. Yes, it is being given by whom? Newton, wherein he related few important factors. So he had observed that object which is there, okay, it will move towards the earth, it will have certain acceleration, the object will have certain mass. So by observing these things, he gave an idea related with what? The gravitational force. Means the earth or any type of object, if you take this chalk even, it will attract the other object around it towards its center. And it depends upon, means what is the magnitude of force it exerts, depend upon what is its mass, what is the mass of the other object, what is the distance between this object and the other. So it is attracting the board, but the board is not moving towards it. Okay, it is basically because the mass of the board is larger. Similarly, the earth is attracting some other object, apple, which is drawn towards it. Why? Because mass of the apple is more. The force exerted by the earth on the apple will be more. Therefore, the apple will get attracted towards the earth. In the same, if you take size of the apple is very big, bigger than the earth, then obviously the earth may get attracted towards the apple. So here, the force between the objects called as attractive nature force being given by Newton, known as universal law of gravitation. It is called as what? Universal law of gravitation. Means this law is being applied throughout the universe, not only on the earth, not only just in the system of your solar system, that is the planets which are there in the solar system, not even the Milky Way galaxy, but this law will be applicable throughout the whole universe. Therefore, this law is called as what? Universal law of gravitation. So he says that if you are taking two objects, masses m1, m2, they are lying at some distance r. The distance is taken from center of the first object to center of the other object r. So these two objects will exert a force of what nature? Attractive in nature. Okay, and the magnitude of the forces being exerted is found to be depending upon mass of the first object, mass of the second object. How? Directly proportional to product of the masses, means m1 into m2. As well as it is depending upon the value for r, distance. So if the objects are closer, the force of attraction will be more. The objects move farther, the force of attraction will be less. Means the force is depending upon the distance inversely. Inversely means like this. So F is inversely proportional to the factor R square. Therefore, this is taken in the denominator down. So this increases, this decreases. This value decreases, this increases. Inversely proportional to each other. How? Square of the distance, R square. And this is called as what? Universal law of gravitation. And when I replace this proportionality sign, how I will replace it? You have to put a equality sign like this, equal to, and then you have to write one constant here. And in this case, the constant is denoted by letter G. Okay, into M1, M2 whole divided by R square. Okay, so F is equal to, proportionality sign is been replaced by equality sign and one constant. That constant may be anything. Now here they have calculated everything and we are being given with the value, that is G, known as gravitational constant. It is called as what? Gravitational constant, and this constant has certain value. It is equivalent to 6.67 into 10 to the power minus 11. 10 to the power minus 11 means it is equivalent to 1 divided by, after that 1, how many zeros? 11 zeros. It's 1 divided by how much? 1, 2, 3, 1 up till 11 is 0. This is the value. Okay. And the unit for this quantity is a Newton. It is the unit for force. Meter square. That is the unit for distance. Meter, it's a square, and kg. It is the unit for mass. So when I simplify this whole thing, I am getting the unit for G, and it is equal to Newton meter square per kg square. So this is Newton, this is kg square, this is meter square. So meter square when it comes up, it is Newton meter square. Kg square when it goes down, it will be per kg square. So Newton meter square divided by kg square will be the unit for G. And remember its value, it is equivalent to how much? 6.67 into 10 to the power minus 11. So remember that this is the universal law. The nature is attractive in nature. Means the objects will attract other objects towards it. There are certain laws which will be repulsive in nature, but the gravitation law is attractive in nature. Okay, so this completes the important law that is called as Kepler's laws and the introduction part of it. Thank you.